I'll say, hey, hello and welcome to the show. It's me, JP. It's time for John Park's Workshop. That glare is going to bother me. We'll move this later. Oh, don't fall off the thingy. There, how's that? That's better. That gets rid of the glare. So let's see. Hey, thanks for asking. I am going to pop over to the Discord chat there. And I'll also say, if you're wondering where the chat is at, and you are somewhere like Twitch or Facebook, you might want to head over to our Discord. It's right there. It's adafruit.it/discord, and that will take you to our server. Then look for the live broadcast chat channel. You can see it highlighted right there. That's where the conversation is happening during the show. So come on by and say hi. Hi. I had a question from, how's the construction? And someone asked about the roof. It is ongoing, but after some major noise and dust and insulation particles everywhere, I have cleared out and cleaned up a bunch of stuff. In fact, it gave me an opportunity. You might not be able to tell, but this has previously been an enormous mess of stuff that just gets shoved to the side, and I managed to do some organization and cleaning of that. So I'm actually better than when I started. And the workshop now has insulation on the roof, and a new roof, and a vent fan. And I'm curious if you can hear that vent fan. They told me last night they couldn't hear it over the iMac mic, and I doubt you can hear it over the lav. But there is a vent fan. There was not before. There was just one of those whirligig things. You may remember when it would sometimes squeak before I oiled the thing. It was... that one is gone, and a nice new one with an actual fan that I can switch on and off is in place. And that'll help a lot with just pulling out some of the heat during the warmer months, which is most of them. So, yeah, let me know. I'm curious if that's an ambient background sound that's that you can perceive over the mic. It's probably not too loud, I'm guessing. I see it on my little mic meter that it's aware that there's background noise, but hopefully it's not too bad. Also, I want to say hello to the people over in our YouTube chat. So hello to Dave Odessa, Bot Zerker, Gary T. Thanks for stopping by. Thanks, Andy. Andy Calloway says it's about the same as the AC, which I'm not even running right now. I had it running earlier. It's in the 70s here, so not too bad. But now I've just got the fan pulling some air out. All right, so that's enough about that. What's going on the show today? So I've got a coupon code for you if you want to go and buy some cool stuff over on the Adafruit store today at a discount. That'll get you 10% off. I'll show you that in a second. I have a little 1-minute wrap-up of this week's product pick. I've got a CircuitPython parsec for you. What else is happening? The project status. So we're I'm almost done with the code for the Power Wash Simulator controller, which is really exciting, a lot of fun. It's been a cool collaboration with Cedar Grove over there in our chat on a bunch of cool stuff about calibration and offsets for this 9DOF sensor. I'm going to put a guide together on that. I've actually started it already, should be pretty quick. And then I'll be jumping on to the Pokemon automator using a Pico. Also, that should be a pretty quick project, so I hope to get a couple of learn guides out pretty quick for your viewing pleasure. Then after that, I've got some neat stuff, more stuff involving Lego, I think. I think I'll be doing another Lego project for the holidays. Dun, dun, dun. And there's something else in there too. So lots of cool stuff coming up. So let's see. First off, I'll say, if you want to go over to the store, head to adafruit.com. I know some people were able to pick up a Raspberry Pi 5 last night during the Ask an Engineer, so hopefully we'll be getting more of those in stock. I think we sold through a couple hundred of them. Does Pi 5 just get you there? Raspberry Pi, I gets you to the, there it is. Yeah, so the 4 gig was the one that was in stock last night. It's out of stock now. And then there'll be an 8 gig coming at some point. I did not bother picking one up yet because I don't have any bandwidth or plans to do a Pi 5 project for a while, so I'll wait. But hopefully, if you're excited about getting one, keep an eye on our social media and watch our live streams. I think that's the best way to be aware when those come into stock. We don't take pre-orders on those. Phil talked about this last night. We don't want to take your money when we don't have something to ship you and have you play that frustrating game. So it's the policy of the Adafruit store that you can buy it when it's in stock. Otherwise, you can get on a waiting list, but we're not going to accept your order, no pre-orders. So I've teased it. There it is. Filthy. That is the coupon code today. So if you want to go over to the store, pick up some cool stuff. You can tell I've got construction dust on my mind as well as the Power Wash simulator game. They are coinciding nicely. And so that's why your coupon code today is filthy. If you want to save 10% off, go to the Adafruit store, buy some cool stuff, throw it in your cart, and at checkout time, you will fill in the little coupon code form with the word filthy. Sorry, I know. Speaking of the Adafruit store, you can also get some free stuff. So the coupon code, that applies. Here, let me move that. Make it look like it's part of my shirt. There you go. So you can use the coupon code for 10% off, but you can also get some free stuff if you spend certain amounts of money. If you spend $99 or more, you will get a PCB coaster with the gold Adafruit logo. Hey, how are there still mosquitoes around? Get out of here. Did I get them? Nope. You can get the KB2040 for free if you spend $149 or more, and that stacks, so you'll get the coaster as well. At $199 or more in the continental United States, free UPS ground shipping, and for orders $299 or more, you'll get all of those and the Circuit Playground Express for free. So those are the free offers. If you're wondering about those, you can go to adafruit.com/free. There's nothing you have to do to make these happen. They just automatically populate in your cart when you hit those certain price points. So go buy some cool stuff if you want, and I mean, I'm not going to make you do anything, but if you want, and save 10% with Filthy. That's your coupon code for the day, and that is good until about midnight tonight East Coast time. So you have a little bit of time to use that. Let's see. Speaking of saving money, that is one of the key features of my Tuesday show, which is JP's product pick of the week. Stop by every Tuesday at this same time, 1 o'clock Pacific, 4 o'clock Eastern, except this past week it actually had to get pushed an hour due to some construction stuff that was happening. So I pick a product. I am able to get the new product team to put aside a lump of them, usually 100 or so, will get stashed before the show. So even if you see that it's out of stock right before the show starts, You'll know what the product is because the YouTube thumbnail gives it away and some other places. But if you go and you look and it's already out. In fact, it'll go in stock right when the show starts, and we have usually put a 50% discount on it if it's an Adafruit product, because we can't always do that with stuff that isn't Adafruit. We don't have the margin for that usually. But on Adafruit stuff, usually 50% off. And then I'll give you a demo of it, and I show you some code. And then I like to do a 1-minute recap, and this is it right here. It is the piezo driver amp, Stemma PAM8904. Here are the little gain switches. This actually is a AC element, and so it doesn't really matter which wire gets plugged in where. We have a 3-pin JST, and plugging that into a Metro RP2040 there. And you can see I've got my 3-volt power, ground, and then I'm running off of pin D5. I'm going to do a little reboot. So you should be able to hear that pretty well. Quiet this thing a bit. So that's the 1x gain, and that'll turn it off. And that is it. That is my product pick of the week. This week it is the Stemma Piezo Driver PAM8904. Yes, indeed, that was the product pick, and I'll actually be using that inside of the, what do you call it there? Pressure washer gun. I'm using that now for some feedback, which is really helpful. In fact, I'm really starting to get addicted to having little beeps as feedback for things like when your microcontroller is restarted or when you need to do a certain thing. It's actually really helpful. So I'm really enjoying having that driver board plugged in on this cutie pie for this project. You might see me do that more in the future because it's super helpful. All right. Next up, how about a CircuitPython parsec? CircuitPython Sorry if there was an echo there on the song. I forgot to turn my mic off during the song. All right, for the CircuitPython parsec today, I wanted to show you how to use a special type of print debug in your code. So what you'll see here, I have a Pi badge, and right now when I press the buttons, you'll see it's printing out both onto the screen and onto my code window REPL there, the name of the button that's pressed. And you'll also see I am blanking out some of those LEDs when I press a button. I also have some dimming happening based on the little light sensor that's on the front of the Pi badge. So this is typical print statements, which, let's say I want these. This is what I want this to do. But sometimes when I'm debugging, I want more info. So you can see right now at the top of the code it says debug equals false. I'm going to change that to true and resave the code. It'll restart here pretty quickly. And now you'll see I'm doing more. I'm printing out light values, and I'm also printing out when I release a button besides just when I press it. So I'm getting more info here, and you can imagine there can be lots and lots of info you're doing in your project you want to see for debugging purposes that you normally don't want to see. So what this debug print process involves is a special function that's been created here. It's actually pretty simple. Function is defined as print D, and then it has an input of a line. It's going to be a string that it's going to print. And then this is the key thing here. This function will only do something if debug is true. So when that was set to false, it just kind of does nothing. But when it is set to true, it will print the line. So you can see here I've got my pressed button line in the sort of normal way, print, and then in parentheses whatever I want to print. But you can see here for both the LED, so here for the LED light, So here you can see for the button release as well as the light sensor value, those aren't a regular print statement, those are actually calling that function. So these say print D, and then we're using F string formatting so that we can put inside of quotes any variable names we need as well as plain text, and those are inside of one single line. So now with that debug true, we get lots and lots of info, but in the end, if we want to calm that down, we're done developing, then we're going to set debug to false, and resave, and now we don't get flooded with information, we just have the key stuff that we need for the project. And that is how you can use print debugging in your code inside of CircuitPython. And that's your CircuitPython parsec. And I wanted to say this was something that, as I've been collaborating with C. Grover on the power washer project using the 9DOF sensor, we had tons and tons of possible things to look at while debugging, and sometimes it was nice to quiet those all down. Sometimes you'll go and you'll say, okay, I'll make a debug statement at the top, and then each time you go and print, you have to wrap it inside of an if debug. This really saves you from having to have those sort of 3 extra lines in your code, and instead just change all your print statements that you don't want to see when you're not debugging to print D, and it takes all of that off of your plate, which is really nice. So thanks to Jan C. Grover for this idea of doing a little special print function for debugging purposes. All right, let's see, what have we got next? So one thing I wanted to do is actually just a little kind of fun update going back to some of the Lego color stuff. So if you're not aware of it, this is, I'm going to go to Adafruit Learn. And 1 second. Let's go to Brick Tunes. That's the Lego synthesizer glove I made. When I was working on this project, I wanted to identify 12, in this case, colors that would work really well for sensing with the color sensor. And I wanted to dive into what is the current state of brick colors, what's the retired colors out there. So I did a big deep dive into that. And actually, if you look in the guide, I have some info, including a link here. Let me check out this link. This is on brickset.com, and this is a really nice list that you can sort it based on solid, transparent, and some of the other specialty colors. You can also say, I just want to see the current colors. There are 42 current colors as well that are solid, as well as go and, whoops, I don't want a coupon code, as well as change the status to retired colors, or 60 retired colors. So this part of the info that was interesting that showed up here was the fact that Lego did not publish their color names for a long time, and I mentioned this in the guide. So there are differences between the names of the colors that you'll find on Bricklink and on user-made creations, even the Bricklink Studio program. These color names the community came up with before Lego had made official what they call the colors internally. I think it might have been in 2011 that they published something, or maybe a little earlier than that. So you'll see I have referred to both the Bricklink color names, and that's what you'll find them in most of the used auction market, as well as the Lego color names. One thing that I thought was really cool is in 2016, Lego updated their color chart. This is the Lego Molding Color Palette 2016, and this gives you the solid colors. There's a glow in the dark in the upper right corner there. There are, excuse me, some metallic colors over here, and then the transparent colors. I really love this sort of periodic table of the elements thing, and I looked through the stuff that I'd collected largely for this project and found that I had enough colors to replicate that, plus I removed, I think, a color that got retired from that list and added a couple that had been introduced since then. So this is the current complete color chart from Lego, but this is temporary because what I really want to do is the flat tiles to look a lot like that chart. So I'm working on a periodic table of the colors chart there. There are some online. There's a company who sells a pretty nice looking chart that you can find online if you look around. But I wanted to build my own with these square tiles, or maybe even make them 4 times bigger and do a big one. We'll see. So anyway, that continues to develop my Lego color obsession. So I wanted to show you the latest progress on that. And you can check out the rest of the guide here for info on how to build that, how to code that, and how to play that. So that also, I had mentioned that I would include the Bricklink instructions for putting together that base plate thing that I built to display the colors and to play on. So this, you can now click on the build on Bricklink. This is a, you can go to the full parts list on here. You can buy parts, do the easy buy, and it'll find as few stores as possible to get all the parts in a build. I think it costs about $50 to get all the parts that are shown there. And you can go through the building steps either right here. And these are neat because these are actually 3D models in the build, so you can take a look at how this was put together. You can also download, and I think I just included the PDF download link in the guide if you want to get a PDF of it, so you can just view that on an iPad or something while you're building. It's a nice way to do things. But this is a lot of fun to use Bricklink Studio to build your model, as well as to develop the instruction guide for it. Let me see if I go back a step. Here's this BrickTunes instructions that will open up the PDF, which you can use images as well. So that's a 3D render I had done of the build, and then you can see it puts together the instructions really, really similarly to the way Lego does their official instructions, which is great, including things like highlighting in red the parts that got put on during that step, so you don't get confused about which ones are the new ones in a step. And I'll scroll quickly through this. You can see this well overbuilt, unnecessarily engineered, robust thing. You could just throw these colored Lego on your desk and use them without this thing. So I'm not encouraging you to build this. I just wanted to share what I had put together. But really a lot of fun to put these together. So that's my update on that. And now that brings us to Power Wash Simulator updates. The first thing I want to do, let's jump over to the bench. I added, if you saw this on, let me move some stuff out of the way here. Even when I clean, there's still stuff, too much stuff. You may have seen on Ask an Engineer, let me get that out of the way, last night that I've got the Wii Chuck, that's the Nintendo Wii Nunchuck add-on controller. These all run over I2C. We have a little adapter board that makes it easy to use over Stemma QT, so plug and play. This plugs into that little board. And you can use the Wii Chuck for added control. So I've got the pressure washer handle. This has all the parts in it. We'll take this apart and look at it and talk about the current state of it. So this has the IMU, the 9DOF sensor that we're using for the targeting stuff. But that, other than tap detection, which I've got working there for changing out my nozzles, which is kind of cool. You can even just shake it to do it. That's not a lot of control. There's not a lot you could do in the game that you need to do. Adding the Wii Chuck gives us pretty much all we need for regular run and gun type of play in a first-person shooter. It's limited, of course, compared to 100 and something keys on a keyboard, or 87, I think, in this case. But by adding the Wii Chuck, we get WASD, W-A-S-D, for movement, forward, back, strafe left, strafe right. We have a trigger button, the Z button there, the big one, for actually shooting the water or not shooting the water in this case. We have the little C button here, which I'm using for a few different things. So Z is always going to shoot the water. C we use for rotating the nozzle. So if you have like a wider spread nozzle in this game that's shooting water, sometimes the side-to-side direction you want to flip that water pattern to be wide this way. So this just toggles the nozzle this way. However, I've also got the accelerometer that's built in here, so we can use that as a modifier in one case. So I can tip it back like this, and if it's tipped all the way back like this and then I press C, instead of flipping the nozzle, it actually allows us to enter the targeting offset mode, which is what we're going to use to reorient in case we are in a different room playing or we move the laptop or whatever it is. So to trigger a thing we don't use that often, I'm having this point straight up and then I'll press C. When I tilt this down, it is toggling the sort of dirt overlay. You can highlight the dirt in the power washer game, pressure power wash simulator. So I do the down action to just highlight briefly all of the dirt in yellow so you can find that one little missing bit that you can't seem to get. But I'm also using, when it's in the down position, if I add the modifier of the C button, we are, I can't remember what I'm doing right now, we'll look at the code. I haven't played with it much, I've just been testing it. And then we also have roll, so I'm able to use these for crouch, go prone, and stand up. It's just a toggle that cycles through those three states. And this is jump. So adding this gives us a ton of extra control. You can see why Nintendo came up with this to add to the Wii remote, which often you can use it like that as a pointing mechanism. So one thing I wanted to do is, and I don't think I've done this in a long time, and Jam was asking about this, is go ahead and take it apart and see what's in there. So let's go over to the workbench. I'm going to focus this camera first, and we'll get it pretty close. That should be pretty good. So let's head over here. And I promise I will do a demo of the actual gameplay so we can see this in action in a second. I just want to set my phone here to show me Discord so I don't miss any questions or things. Let's see, where is the screen control? I just have to tell it not to turn off. Auto lock, oh, you're already set to never. Okay, that should be good. So let's set that right there, that's good. Okay, so here, get some things out of the way. Oh, here are bricks. This, by the way, was my previous color palette of all of the current colors. This is the one brick that comes in every, I think in every, or the most current and retired colors. All right, so I'm gonna move the blaster gun there off to the side. And here we go. So I don't know if this is one of the aftermarket ones that we sell on Adafruit. Sorry, I'm gonna tighten up that focus a little more. The official Nintendo one may use a tri-wing screwdriver. I can't remember. So I've got one around here somewhere. If you run across a aftermarket one, it's probably a small Phillips. If you have a Nintendo one, it may be the tri-wing, which they use to kind of keep people from going inside of stuff and breaking it. So this one just requires a fairly long and small Phillips. This might be a 0 or a 00. Might not be marked, it is not. And oh look, the screwdriver is magnetized enough to store my screws for me, so I'll just leave that there. So I'm guessing we've got a little clip, a little plastic clip here. So I'll grab a little spudger type of thing and see if I can release that clip without breaking it. There we go. Yeah, so there's just some little retention clip right there that clicked into there. Just needed a little squeeze. So there's the top molded piece. I'll zoom out just a little bit. There we go. And you can see a lot of effort is put into supporting the board that the thumbstick is on. So a lot of this is pressed into this board where the thumbstick lives so that it doesn't wiggle or snap. Then we have pretty much the whole thing on one little assembly that pulls out. It's a little strain relief on the cord. It should just pull out like so. Then the base of the case, again, more supports and bosses and screw hole cutouts. And then there are two buttons in here. So these are the Z and the C button, molded plastic, that actuate the little soft buttons. And these look like they're just a typical conductive pill type of button. We have three, a ground and two switch lines running from there to the little board. This is clipped onto the little PCB, again with a little clever plastic hook. It would actually kind of be interesting to see how close this third-party one is to the Nintendo design, because sometimes it's easier to just copy as much as possible than come up with an original design. Sometimes third-party manufacturers want to do something different or want to make it less expensive to manufacture because they're not as worried about the quality as Nintendo is. So the little button PCB is pretty much just slid into this support, and you can see there's a little hole that a little plastic stud comes up through. So I don't think I'll pull that out because there's a decent chance I'll break something trying to get that out. That's in there snug. Then we have a 2 potentiometer thumbstick with a little hat switch on there. And you can see with these are nice. A lot of the design of this is actually just sort of dust protection for not getting junk inside of the controller. So this is pretty snug up to here on the top of the case. The joystick part is really just this little bit here at the very top. So that's 2 potentiometers that get twisted as the stick moves, and it's got a spring return on both axes. Let's zoom back in a little closer. And by the way, if you're noticing me looking over the top of these glasses, these are just some of my reading glasses because I scratched the heck out of my regular progressive ones that have no magnification up top, which is, I don't need it for seeing the monitor, but I do need it for the close stuff. So I've got glasses on order, but in the meantime, I'm just going to be using readers and doing like this, sorry. Okay, so now here's where pretty much everything is on here, and what I don't have is actually decent enough magnification to look very closely at that. Let me see if I can find a lens. I may just let me grab a second pair of glasses. I have like a visor with some good lenses, but it is not here in the shop right now. And I've also got a microscope, which is really helpful for these part numbers. Let's see what we can, and the iPhone helps a lot too, so let's see what we can see. Yeah, I'm gonna need, all right, let's try it with the phone. I'm just gonna use the camera, in fact. All right, so here's what we have. You may want to look at these too. So ATM HK218 and the BM807 V6 from Shanwan. You can see here the I2C line. So voltage, serial clock, serial data, and ground. That is the set of lines along with, I guess there's a doubled one there that's listed as R1, R2. I'm not sure how they're using that, if it's an address thing maybe for having two of these, two players, I'm not quite sure. Well, no, these don't plug right into the console, though. These go into the Wii mode, so I'm not sure. However, most of that there is what you'd expect from a normal I2C, but there is one extra line, so that's kind of a question I have. If anyone in the chat knows, by the way, I can't look at my phone now, I'd be curious what the fifth wire is on the Wii Chuck standard there. And then up on this end, let's take a new picture. So there's the ground Z and C ribbon cable for those buttons. This is mysterious to me. I do not know why this little unnecessarily cool little set of traces lives here without any solder mask. What the heck is going on there? I do not know. And then this guy is actually a little too blurry. CY6A is this marked as U2 on here. And this is not a Nintendo one, so it might not be as well documented on the internet. So, but let's look and see. I'm going to go back over here for a second. Let's look and see if we can get any info on the chips that are on there, because I'm assuming one of those is the IMU, and one must be dealing with I2C. So let's jump back over here. I'll bring my chat back up in case anyone has info about this or thoughts on this. That would be cool. Actually, I'm going to bring up my browser and very dangerously just browse for the name of the. So how about let's try this one, Shanwan BM 807. I got two dashes in there. V6. Someone on the Reverse Engineering Stack Exchange has a gamepad with this in it. I have a gamepad with a Chinese Shanwan BM blah, blah, blah. Okay, it's a different one. MCU clone. So that may be the microcontroller there. And then let's look up. I'm just going to take some letters off of there. Sometimes that helps. No, this is getting us CRISPR virus stuff. All right, so not a lot out there on that. Let's see what this other ATMHK218. It's a two-wire automotive serial EEPROM. No, not quite the same number, though. Let's try it in quotes. Here's a DigiKey forum question. Similar part number was past produced from Atmel. It says that is an I2C chip. All right, well, that's as far as I'm going to take that then. Something in there is accelerometer, something in there is a little brain, and it may be that the I2C, yeah, is probably just built into whatever this microcontroller is. So I'm going to guess that maybe, I don't know, that Shanwan looks suspiciously large to be an accelerometer. Could be that little, what was this guy's name? That little one looks a little more accelerometer like CY6A. Let's try accelerometer. You can really lead the witness, and I don't have a clear enough image of that to know if that's, oh, CY6 accelerometer? Yeah, I think that is the accelerometer. Sure looks like that type of package. GY6. Ah, maybe that's it. Yeah. Okay, and it looks like maybe that's one that we have on our one of our boards there, a triple axis accelerometer. Yeah, GY. Not CY. Let's see. Yeah, thank you. Jeff in the comments said that it has 6 connectors. Oh, was I not counting right? 4 of them are active: ground, 3-volt, data, and clock. Okay. Yeah, and on my board, the ones that are labeled R1 and R2 were jumpered together. Those pins were blobbed across. So very interesting. All right, so that's all that we need to look at there. You know, like a lot of these, it's not, unfortunately, too exciting to look at because it's just a couple of, at least there's no epoxy blob, but it's just a couple parts on a little tiny PCB. So now what I want to do is let's look at, I'm going to set up for the, squeeze this in a bit, set up for a demo of the Power Wash simulator so you can see that. Let's go to a full screen of that. And what I have running it, I've just got a Windows PC gaming laptop here, and has HDMI out, which I'm going to run to this monitor so we can see things a little more clearly. So I'm going to power this off of its ginormous power brick. I don't know what battery life this gets running its GeForce card in there, but it's probably not much. So I'll just keep it plugged in. All right, and then I've got a HDMI cable right there. Oops. And let's see if it sends that signal out. All right, there it is. I'm sorry this isn't very bright. I don't know if I can do any brightness stuff. Yeah, it's at full brightness there. Okay. I'm going to turn this light off here so it makes it a little better. Unfortunately, this camera wants to do a little auto correction of the lighting. So let's hook up the controller. So we'll see this in a second when I take this apart, but what I was mentioning earlier about piezo driver that's in here is we'll hear this beep when it starts up. It's actually a double beep. And that's to tell me that we're about to do a targeting offset, a little quick targeting offset procedure. And what that does is it calculates the difference between the calibrated values on the 9DOF sensor that are based on a previous little calibration routine we ran, which basically involves pointing the thing at true north, so you use your phone or a compass to tell you true north, point it at that, collect some values, do a little dance. The gyro and accelerometer seem to auto-calibrate really nicely on this sensor. And C. Grover has a great write-up on this process that I'm going to be including in the BNO 055 guide and linking to in the Power Wash Simulator guide. But you'll just need those values one time unless you move to a different location on the Earth. But as long as you're kind of in the same basic location, you won't need to do that every time. But what we do need to do is say, okay, if I was playing pointed this way and now want to play pointed this way, I want to create a relative offset, a targeting offset, so that center is center again. Okay, so I've got a nice long USB cable here. I'm going to plug this in. So you're going to listen for a double beep, and that's going to say, okay, we want you to point it where you want to play the game. So point it at the center, and then we'll hear a confirmation beep about 2 or 3 seconds later when it's finished. Beep. Beep. Okay, so you see, oh, I have to turn on, I have a debug mode where it's actually not moving the camera. That's okay, you know what? I want to demo some of the other stuff while we're not worried about where I'm aiming this, okay? So you can see here I've got a lot of beeps happening, and that's because of what I'm doing with the nunchuck. I've got my nunchuck cord as well as my USB cord coming out of the bottom of the handle here. So the nunchuck is going to do all of my, let's see if you can see that, yeah, all of my strafing movement, right? So I don't have camera control right now, so it's just strafing forward, backward, right, left. So that's just sending HID commands of WASD. And then when I tilt this up, it beeps to say, okay, you're in this up modifier position. If you press C, you're going to reset your offsets. There it goes. It actually accidentally did its normal C button function, which is switching the angle of that nozzle. But if we're up here, I got to check my code why it's doing both. So that's sending a HID R to do that change, I think it is, of the nozzle angle, but that's the sound of, okay, you've just recalibrated. So tilt it forward again. This should only be doing the nozzle stuff. And if I tilt down, you'll see it's highlighting the dirt. And then did I tell it to do something when I'm? No, I don't think I have it doing anything yet on down tilt and C. Then I mentioned roll. So if I roll the cursor or the Wiimote, Wiichuck, it will crouch. If I do it again, it'll go to prone position, which is really helpful for getting up under those fenders. And then if I do it a third time, we go back to standing. So those are the 3 positions. And then if I tilt left, we'll jump. Boink. And that'll help you if you want to spray and get all that gunk up there. So let me plug this back in to my computer here where I can edit the code. And this is super dangerous because I've got HID commands that could be spewing out and doing who knows what to my broadcast. But I'm going to go over and open up the code that's running on here. Are you it? No. Oh, I got to unplug this Pi badge or turn it off. 1 second. There you go. And okay, let me show you this. So cursor false, and that's just helpful during coding. If you have this plugged in and you're testing other stuff, you don't want it moving your cursor around unless you had a way to like set the gun in a little holster and recenter the offsets. Then it won't move on you. But I'm gonna change this to true and save. And then before that wreaks too much havoc, I'm going to unplug it. And now we'll plug that back in. Okay, so again, it's going to start up. Wants me to point at center. Okay, it's now got those offsets. So now you can see as I move the actual gun around. Now let's say I want to adjust this. I want to be pointing straight ahead instead of a little tilted up. I'm going to go ahead and switch the camera view again to this one. So here I want to adjust my offsets. So this is the angle I want. I'm going to go up, beep beep, and you see it stopped spinning around. And now I can hold it still instead of pointed up. I can hold it kind of level with the ground. Okay, now on my controller I can press Z to turn on the water. I can use the thumbstick, and especially when you're just standing still, you can kind of put both hands on there. You don't really need to use other than the trigger on here. The trigger can be a toggle, even just in the game. It has a mode where, let me get down a little low. Look at that. There's a mode where it will just toggle. The trigger doesn't have to be held constantly, so that's a choice there. I can move around while I'm down here. We can even change our, oh yeah, so here you can see, look at the color of the tip in the game on the pressure washer nozzle. It's yellow right now. I can switch that to green, which has a wider tip, white even wider, and then go to red. There we go. Red is like, hey, I wouldn't do that to my stuff because it would probably just scratch the heck out of it, but in the game that's great. We get this like needle-like performance. So that's pretty cool. This is the tap detection, again, the Cedar Grove maker created for the BNO 055. It does not have, I'm going to hit escape on this so our camera doesn't spin as I'm talking. You stop. There's not a built-in tap detection routine on that sensor, and so so Cedar Grove wrote a little routine to determine some accelerometer values that were very different from each other between samples, and so that's in the code, and we'll talk about that. So let me see. Was there any other? I think that's all the features that we have. Again, if I come over here and want to, let's say, Todd just mentioned highlighting the dirt, so I'm just going to tilt down. Oh my God, it's filthy on this side. Okay, that's fine. But you know what? I want a wider spray to start with, so the white one. Whoop. Oh, okay. So something, I don't know what's happened. I want to fix my my offset. Something went crazy. Okay. Shoo! I've calmed it down. I don't know what that was about. But you can see it's really nice to be able to, even if you're not moving the game machine around, to be able to reset the offsets. So let's say I wanted to point over that way and have that be center. Now I don't have to point at the screen for whatever weird reason. Now I can come down here and clean this off. And let's say I want to get some of those little pieces of dirt. I'm going to go to a more targeted, like that. Yeah, look at that. Oh, you know what? I think the mode I was going to switch to, let me see, does this switch it? There we go. So I did have a mode for this. So down, whoa, let me stay mostly centered. Down on the Wiimote and the C button switches to this gun aim but no head look. So you can see the camera is fixed until I reach the edges. So this sometimes is, let me tap to a different, whoa. Sometimes this is helpful in the game to sort of keep the camera view put. It's actually a little nicer if you get nauseous in first-person shooters. It's kind of nice to be able to aim the gun but not change the camera. So that's what that mode is, and that's by tilting down with the Wii chuck and then pressing the C button. Stand back up. Let's change that nozzle and let's jump. We can jump onto that. That's hard to do. Oh, I made it. Okay, now we're on top. Now we can clean the top of this thing. And again, I want to recenter it, so I'm going to do my offset dance, and now we're cleaning the top. I want to hold the camera still. And there we go. Clean the top of this thing. All right, that's the demo of how it's working. Let's take a look at code here. Let me know if you have any questions up to this point, and then we'll take it apart. But we'll talk about how it's working and then show you the guts of it, which will actually give me an opportunity after the show to take some final pictures of it for the guide. So that's part of my reasoning there. Okay, so right now it's going to mess with my cursor if I touch it. If you lay it down and then start it up, it's basically, it thinks it's pointed at 0. It's not, it doesn't detect any movement, so you're good. But if I bump it, my cursor on this computer will go wild. So I'm going to set the cursor variable to false. And now it won't care if I move this around. I can do fun stuff, however, if you look at my code. Sorry, I wasn't showing that a second ago. If you look at the code here, if I tap this, the tap detect actually sends a mouse wheel click, a roll, like one increment of a mouse wheel, because that's how you switch between the nozzles in the game. So I'm going to put focus in my code window here. Oh, I got to scroll down a bit though. Uh-oh, it's angry at me. I have some USB HID thing that's mad. There we go. So just let me scroll down. So if you look at my code very slowly, this has a kind of a slow scroll on this machine. It might just because of the resolution of the monitor is high. But you can see that's the command that gets sent there. If you look in my code window, if I press the C button, that types R. If I tilt it down, it's typing C there. I'm also getting autocomplete, so that's weird. And we can also tab. One of these is tab. I forget which one. Who among you is tab? Is it down? Yeah, there you go. So each time I tilt that, we get a little tab. So those are the joys of developing HID stuff, is sometimes you're fighting yourself, so you kind of have to set things carefully down. Okay, so this code is getting pretty close to finish. You can see here I've got a little list of, turn this light back on, a little list of the functions there up at the top in the comments. You can change these. Some of these are, especially the HID key codes, I've just listed in these constants here. So you can see we've got a bunch of libraries we're bringing in. The constants here for debug and cursor, which is kind of a debug thing. There are some variables here that you can set to adjust things in the sensor. So this sensor ratio thing, this was a really huge idea that impacted the quality of the cursor movement a lot. The cursor movement on its own is great, but once I added the Wii stuff, the BNO was fighting with the Wii messages, and so it just was sort of stuttering the camera quite a bit. In fact, if you saw last night on the show, the version I had a kind of a steppy camera. Now it's really buttery smooth, and that's because the sensor packet factor is set 10 to 1. So you get 10 BNO 055 messages for every one Wii Mote message, which is great. The horizontal rate and the vertical rate are what you can tune to essentially impact how fast the camera tracks with the motion. And since we have a wider screen than it is tall, you could probably tune these to be the 16:9 ratio, which I don't have in here. I have kind of a 1:2. Then here are some of these keys that you could change out. So rotate nozzle happens to be the R key on the keyboard, so that's what I'm using when I press the C key in normal mode. And you can see I have a secondary, this is kind of the modified version of that C key, or that C button, and that's only when I'm pointed up, and that's what, or rather when I'm pointed down, sorry. When I'm pointed down, then we're calling the letter C, it's a little confusing, which is what switches the aim mode so that the camera is locked. These are some values for accelerometer of the Wii. So I've got at what value do we consider the thing pointed straight up, and at what value do we consider it pointed straight down for those modifiers, same with roll left and roll right. And then these are the thresholds and the debounce times for tapping on, just a single tap on the BNO 055 here. And I found that with this pretty low threshold of 6, that allows me to just kind of flick the gun to make it switch the nozzle, which is nice. It means you don't have to bring both hands together to tap it. Then we're setting up I2C. We're setting up mouse and keyboard stuff. I have a little list of the WASD keys, just because those aren't going to change if you're using the joystick for movement. Those are going to be WASD. Set up the nunchuck on I2C. Then we're creating the instantiation of the BNO 05, also over I2C. Here's a little beep function, and this is just a convenience function for using tone, which is part of Simple I/O, and you just feed it that function a frequency and a duration, and it has some defaults, which is what we hear sometimes. And here is that, if you remember just not too long ago, the CircuitPython parsec where I showed the print D function. There it is in action. And in fact, let's do a quick demo of that. I will connect to the, so you can see I'm doing stuff here, but we're, oops, put my cursor down here. We're not seeing any feedback, so if I come up and change my debug to true and resave, we should see a bunch of feedback happening here as, so there's some joystick info and some, where's the mouse pointing, and so on. So that you can go through and selectively. Sometimes it's too much to have it all at once. But that's the idea behind debug. I don't want to see that stuff now, so I'm going to set debug to false, save, and then all those print statements stop harassing us. You can also see there what just happened. So this is, like you saw me do, I think I have it do the offset dance or offset math on startup after the double beep, and I just point the thing at the center of the screen, and this says, okay, we've got some offsets off of 0, so 0 would be pointed over here, you're now pointed here, and the way we do that is these XYZ values. So those are what printed out there, and those print out even when you have debug off. Right now I might change that. Okay, then here is a C. Grover function for calculating the distance between reference and measured points in a universe. The point position tuples can be colors, compass, accelerometer, absolute position. We used a version of this, I think, for the color comparison in the Lego project, if I'm remembering correctly. So it's finding using list comprehension, it's finding the difference between some values to be able to compare them and find out their delta. Then these are offsets that I created, and I've made a link here in the BNO05 library. There is now an example script, example code called BNO055 calibrator.py, and I'll put instructions or a link in the guide. If you run this, you want to run this, this is going to give you your kind of your truth, your true north, your calibration offsets off of the true north and the accelerometer and gyro. So that you just kind of need to do once unless you moved across the country, and then you might need to do it again. But those are my starting point, and then where I'm pointing it in the game to be center is that offset that you saw it generate at the beginning. That's also the offset that happens when we point the Wii chuck up and press C. Then I have some states that I'm keeping track of so that I can do this stuff and press buttons without it constantly spamming things. For example, the roll state, it's at 1 when it's in the center, it's at 2 when I roll it, or 2 when I roll it to the right, and 0 when I roll it to the left. Then sensor packet count is part of this packet counter that's being used to calm down the amount of data coming from the Wii and just deal with more BNO data, because we want to prioritize that. And then this previous acceleration is used as a baseline for tap detection. Then I'm doing a little beep to say, hey, we've started, print out a little message, give you 3 seconds to point and hold still, and then it checks for this angle. So this is target angle offset variable, which is angle for angle in sensor Euler. That is what's used to adjust where you're pointing from your sensor's 0 reference point. Then main loop here. Okay, so you can see just in the comments here, it says get Euler angle values from the sensor. Euler angle limits are plus 180, minus 180 on pitch, 360, 360 on heading, and 90 to 90 on roll. And we're not using roll. You don't need it. It's too much. We're not tilting the gun sideways like John Woo or anything like that. So that's actually never used, but it is one of the pieces of sensor data that we get. So now we're creating a sensor Euler variable, which is based on sensor Euler. Sensor packet count, again, incremented to deal with the, if we get through enough of those, we can then ask the Wii what it's doing. We're now casting the sensor's data that it's sending, the sort of sensor fusion data of heading, pitch, and roll, and we're calling those with the offset taken off of them. We're calling those the heading, roll, and pitch. So that's actually what we're working with, and that's what can then be turned into mouse data. Here's how they're turned into mouse data. This horizontal move is an integer based on using map range inside of simple IO. So it's the heading. It's this 0 to 360 thing based on the magnetometer. Heading negative 20 to 20 is the band that we're reading. And then that is being cast as either a negative or a positive 127, which is kind of the maximum amount you can send a mouse X movement. Same sort of thing happens with the Y. So up and down, except it's a smaller band that we're looking at, 10 to negative 10, and that gets cast to this 63 to negative 63 that I showed you earlier. And then if cursor is true, so that was that little switch that I flipped, we can tell the mouse to move. So mouse move X a horizontal amount and move Y a horizontal amount. And so that can be anywhere from 1 to 127 going to the right on the screen, or -1 to -127 going left on the screen. Then we have all the WeChuck stuff. So if the sensor packet count is bigger than the sensor packet factor, then we can finally ask the Wii what it's up to, because we've read the sensor, the B&O sensor enough times to go interrupt it for a moment and ask the WeChuck what it's doing. And I think there are some blocking things in the WeChuck driver, which is one of the reasons this is important. So WeChuck joy X and joy Y are variables that I'm setting based on asking WeChuck joystick, and that returns, I think, a 0 to 65,583 or whatever it is. The negative, or if we're less than 25, oh, does that give us, sorry, I'm wrong. Joystick gives like a 0 to 255, 0 to 254. I think that's what it returns. So anything less than 25, we're going to the left, so we hit the keyboard A. When we're not, we release. Anything greater than 255, we're to the right, we send a D, and so on with the other two directions. By the way, this code, I may try to spruce this up. Oh, let's take a moment to appreciate Janiscu found a, oh, it disappeared. There was a GIF up there for a second of a, of a clean van. So I may clean this up so that it isn't, it doesn't think it should be sending release messages more than once, but I don't think it does. I think even though the code looks like, oh, it must be sending keyboard release, the driver, the library for keyboard, USBHID, and CircuitPython just ignores that if it's already been released, so it's not like it's constantly spanning it. Then we go on to our accelerometer stuff. So again, we roll, we pitch, and we acceleration on Z, which we're not using. That's sort of the gravity. You could drop the thing. Are getting picked up from this WeChuck acceleration. Then same sort of thing, except now you can see I'm using states to see, okay, if we're rolled to the left, rolled to the right. If we're pitched up, pitched down, do different things. Some of those include beeping. So if we pitch it up, we'll get a little beep. And then if we're pitched up based on that state getting flipped and we press C, then that means it's time to run the little recalibration offset. You can see that one. Most of these are just pressing keys, but you can see that one. Let's see, pitch state up. So when pitch state is 0, that means I've tipped this up. If I press the C button and it wasn't already pressed, then we are updating the target angle offset, just like at the beginning, to be angle for angular and sensor Euler. Then we do give a little couple confirmation beeps, and then I'm flipping the state to true so that we don't get sort of spurious multiple hits. And then last thing we have here, after some more straightforward press the Z and release the Z stuff to send the mouse left button, which is what actually sends the water spraying. You can change that to mouse right button, and that's a toggle, so you don't have to hold the Z key all the time. You could change that to be a toggle. And the last thing here is the tap detection. So you can see the accelerometer sample is red, and then another one is immediately red as fast as it can. No delay there. And then again, we use this Euclidean distance function to compare those two. If that difference between those, or the delta, is greater than or equal to the tap threshold, then we are going to register a tap, and we'll send this mouse move wheel 1, and that's what cycles between the different nozzles on there. And we give a little beep because it's fun. Shoo! Okay, well, so there we are, about 263 lines of code to do all that, but I am really happy with how well that's working now. I just wanted to, let me set the cursor active again, and I'm going to plug that back in and just show you an outdoor scene, because you can see some of the nice camera movement out there. So true, oops, on cursor. See, it beeped, and now I know I can unplug it because that means we restarted. I love that. Big fan of the beeping. So before I hook this up, actually, I will exit to the menu, career, free play, locations. How about the playground? I'll restart this job. Confirm. So there's the usual. This is kind of a nice chart of the typical controls, which you can see here. Use washer, that's the left mouse button there. Switch nozzles, that's the wheel. WASD for movement. Stand, crouch, prone, that's control. Jump, that's spacebar. And I think that's it. Those are the ones I'm using. Oh, and tab for show dirt. And one other, which is rotate the nozzle. R. Oh yeah, and aim mode C. So we're picking up a lot of those on there. There's some things that we're not doing that maybe you'd want to add. There's a pickup. You can pick up ladders and place them. So that could be another Wiimote thing, like maybe with your roll and a button. There's a lot you could add. All right, so we'll continue. Okay, oh gosh, we're spinning because I wasn't pointed at the screen. Oh, it's okay, there we go. Now we're in business. So you can see this is a filthy playground. Just start cleaning that. And you may ask, if you haven't played this game, why would you not just go with the biggest nozzle all the time? And you want to try it, but sometimes the dirt doesn't come off with the big nozzle because it's lower pressure. So that can vary a lot. Woo! Bzzz, wow, yup. Yeah, you can of course write your name or draw pictures in there. But there we are. There we have it. Power wash simulator in the house. Let's move that soccer ball. They have some physics going on in here. There we go. Want to see where the dirt is? Oh, it's everywhere. Everything's filthy. All right, I'll stop there. Okay, so that's the state of that project. I'll be putting the guide together right quick, so keep an eye out for that. Again, a reminder, if you want to get 10% off in the store today, yeah, Dexter, that is a gross. The playground is so gross in Power Wash. It's disgusting. It takes a long time to clean that. I've played through the whole level. Filthy, that is your coupon code. That's going to get you 10% off in the store today, so head on over to Adafruit.com. Go look for some cool stuff. Let's go back to Adafruit. There we go. Oh, that's the learning system. There's Adafruit. Come to the shop, throw some stuff in your cart. There's some fun banners and things to click on there to get some ideas. When you get to checkout, be sure to type in filthy as your coupon code. You'll get 10% off, and that's good until midnight tonight. Any other questions or things? Let me just scan through questions and comments in the chats. Dave Odessa, yes, a bit of a deep dive in the workshop for sure. Well, I'm going to have to write up the how this works section of the code, and now finally the code is just about done, so it's helpful for me to run through it, say it out loud one time. It'll be better for it, I think. All right, that's going to do it. Thanks everyone for stopping by today. Thanks everyone over in the YouTube chat. Thank you, My Electronic Trip, Gary T, Bot Zerker, Dave Odessa, and then over in our YouTube or Discord, we've got DJ Devin, Todd Bot, Dexter, Janiscu7, C Grover, Jeff. Thank you. I hope I didn't miss anyone. We, I believe, had a deep dive with Scott tomorrow. Check the blog, check the live broadcast chat channel. If anyone knows for sure if he announced that or not, I think he said he was going to. And then we got a whole slew of live streams coming back around starting next Tuesday with the next product pick of the week. And on Wednesday, we'll have 3D Hangouts, Show and Tell, Ask an Engineer, this again, and on and repeat. Okay. Thanks, everyone. See you next time. Bye-bye.
Thank you.